Alright, welcome back everybody. In this video we're going to look at example 2 from the Introduction to Related Rates video. And looking at this example, we have two boats that are approaching a buoy along paths that make a right angle. First boat is 160 feet from the buoy and is traveling at a rate of 30 feet per second. Second boat is 135 feet from the buoy and is traveling at a rate of 35 feet per second. Find the rate of change of the distance between the boats. So, we have one boat over here, traveling towards the buoy. I'm just going to write buoy there. You guys who've seen my artwork in real life know that it's probably better if I just write the word buoy there to represent a buoy, and write, boat A over here, and boat B over here. And they're approaching this buoy at a right angle. We want to find the rate of change of the distance between the boats. So let's try that again. It's not much better. Alright. So now I'm going to label all these distances in my diagram, and I'm going to call the distance from boat A to the buoy, I'm going to call that lowercase a. And the distance from boat B to the buoy I'm going to call lowercase b. And the distance between them I'm going to call lowercase c. And now I have all of this information for the initial state that the problem is in. I know that A is 160 feet. B is 135 feet. And boat A is traveling towards the buoy at a rate of 30 feet per second. So you got to stop and think about this for a second. It's getting closer to the buoy, and so the change in A with respect to time, A is getting smaller as the boat gets closer to the buoy. So dA dt here is actually negative 30 feet per second. Same thing for dB dt. That boat's traveling 35 feet per second. So the length of B is getting smaller. So dB dt is also going to be negative. dB dt is going to be negative 35 feet per second. Okay. And now we want to write an equation that relates our distance to the information that we know, because we're trying to find dC dt, the change in distance between the boats. So we want to write an equation that relates the variables a, b, and c. And this should be fairly easy for us here. From the Pythagorean theorem, a squared plus b squared equals c squared. Alright, so we have all of our information, we have what we're looking for, we have our equation that relates the variables. Now we're going to differentiate this with respect to time. So we get 2a dA dt plus 2b dB dt equals 2c dC dt. And I can divide both sides of the equation by 2 to get rid of all those 2's. So it turns into a dA dt plus b dB dt equals c dC dt. And I want to solve this equation for dC dt, since that's what I'm looking for. So I'm going to divide both sides by c, and I get that dC dt is equal to a dA dt plus b dB dt all over c. And now I want to just substitute the values in to find the value of dC dt. dC dt is equal to A is 160, dA dt is negative 30, B is 135, dB dt is negative 35, and C, well, I don't actually have a numerical value for C, but from the Pythagorean theorem, C is equal to the square root of a squared plus b squared. So I'm just going to take the square root of a squared plus b squared. And I recommend that you do this way instead of calculating the value of c and then using a rounded value. Just make that substitution and do your calculations like this. And so now I'm going to turn to my calculator, and I've got 160 times negative 30 plus 135 times negative 35 divided by the square root of 160 squared plus 135 squared. And I get that dc dt is negative 45.499. And I need my units. dc dt is the change in distance. It's going to be measured the same as the other changes in distance in this. It's going to be measured in feet per second. And again, we talked in the last video about how we can come up with units if we, don't know the right unit to use here. This is measured in feet. This is measured in feet per second. Feet per second. So the numerator of this expression is measured in square feet per second. And the denominator is the square root of feet squared plus feet squared. So it's the square root of feet squared, which is just measured in feet. And if I take feet squared per second and divide by feet, I end up with feet per second as my unit. Alright, that's the end of this video. See you guys next time. Have a great rest of your day.